Welcome back, everybody. We made it through the first week of the new semester. Okay, so we're on week 20, February 8th to the 12th, and we've been introducing this idea of similarity. Okay, but before we start the learning for this week, we've got to do our shout outs for last week. So the first thing we want to do is congratulate all those mathy achievers. Period 4, we've got Alexis Brandt, Emma Contois, Abby Crimps, Mikkel McLeod, Colin McBride, Quinn Moses, Noah Murphy, Jackson Knoll, and Kayla Shearer. In period 5, Kristen Barnett, Spencer Deerdorf, Maya Eckel, Hannah Lee, Arthur Lucan, Devin Martin, and Matt McConnell. And then those folks that really help out during class. Like this last week, we were typing all sorts of things in the chat when it came to scale factor. Remember, we used a real world problem. We picked 3 spots on the planet, had a big triangle, and we scaled it down. Remember, scale factor and proportions, all leading to similar triangles. So those folks that helped us out last week, our shout outs go to Isabel Bennett, Kaylee Bonnet, Alexis Brandt, Courtney Brown, Abby Crimps, Claire Darlin, Daniel Empert, Mikkel McLeod, Colin McBride, Quinn Moses, Jackson Knoll, Cam Odell, Logan Powers, Kayla Shearer. Period 5, Kristen Barnett, Spencer Deerdorf, Maya Eckel, Hannah Lee, Arthur Lucan, Carlene Nolan, Sarah Altman, and Jackson Rookty. We want to thank all of you for giving that extra effort to make our class better. Okay, now this week, if you remember, I keep telling you real world math. Last week, we used the globe, right? And we created a scaled down version of the planet in a triangular shape. This week, we're going to head outside in just a minute. Okay, similarity. If it's a small triangle and a big triangle, but all the angles are the same, they have to be similar. That's called the angle rule. Okay, side, side, side. We already knew that, right? If we have a 1, 1, 1 and a 3, 3, 3, then we know side, side, side has a proportion, right? Multiply by 3, 3 times bigger, or divide by 3. So the side, side, side rule. This week we're going to study side, angle, side. The idea of a triangle in a triangle. And when we do that, it's called direct measurement. If I know all there is to know about the small triangle, then I can predict something big. Serious. So, to help with the real world math, I want to make sure we can go outside, just like I'm going to challenge you to go outside and find something tall. The flagpole, the roof of your house, a basketball hoop, something that casts a shadow. So, in a second, we're going to head outside because there's this big tree outside, and it's casting a shadow because the sun is shining. I'm going to stand in such a way so that the small triangle that I create with my shadow in relation to the big triangle and the shadow that the tree casts. Using similarity, proportions, and scale factor, we're going to be able to predict how tall that tree actually is. I'm serious. So without further ado, let's head outside, field trip time, and get some measurements, okay? See you in a minute. Okay, real world math. That tree, I'm 6 feet tall. We, using similar triangles, can determine how tall that tree is. Okay, welcome back. Phew, you could hear that wind blowing, huh? Okay, here's the idea. Side angle side. That tree casts a shadow. Okay, so look at that photo. The tree casts a shadow a certain distance. All right. Now, I went out there and strategically located myself in such a way so that my head casts a shadow to the same point, to the same point, to the same point. That's where you saw that orange cone. All right? Now, we know I am 6 feet tall. Okay? I'm 6 feet tall, and I didn't use anything measuring. Don't worry if you don't have a measuring tape. Just estimate. Okay? I'm lucky. I wear a size 12. That's about a foot. 1, 2, 3, 4. Remember, if you're doing this on your own, the average person from your nose to the tip of your finger, 3 feet. So try to guess how far 1 yard is and just pace it off. Do the best you can. 12 feet. Okay? I created a triangle. My shadow, 6 by 12. The tree casts a shadow that was 90 feet, okay? 30 paces. I just estimated, right? Each pace that I took was 3 feet. So we had 90 feet and X. We got it. Proportions, scale factor. It doesn't matter which direction you go. You want to go this way, X to 90 is 6 to 12. You want to go this way? We can do that. X to 6 as 90 to 12. Now remember what we studied last week. Cross multiply, right? This times this, this times this. This times this, this times this. You see how it didn't matter which direction we went? We get 12 times X equals 9 times 60, 540. Divide both sides by 12, and X is indeed 45. That tree is 45 feet tall. Hopefully that excites you. Real world math. This week, it's called direct measurement. Triangle in a triangle, the formal math. Side, angle, side. If the sun is shining, it would be cool if some of you that live near Shadle Park went and tried to figure out how tall is the water tower at Shadle Park. Catch the shadow. So this would be the water tower. It casts a shadow. You stand in such a way so that the shadow that you cast lands on the same spot, and you can do the math to guess the height of the water tower at Shadle Park. Isn't that cool? Welcome to Real World Math. Hopefully you're enjoying geometry. We'll see you in class on Tuesday.